Hello and good evening to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss one of the most important concepts in operating system that is referred to as deadlock. To begin with, let us try and understand some of the fundamentals that are associated with deadlock. As we all know, a typical system has in it a collection of resources. It has in it a collection of processes. The collection of processes utilizes the resource set in order to perform its purpose-specific operation. Again, I'm repeating it. A typical computer system may have in it a collection of resources. It may have in it a collection of processes, wherein the process set utilizes the resources in order to perform purpose-specific operations. Let us simplify it with the help of a contextual explanation. Let R be the resource set and let P be the process set. So, the resources from the resource set R are allocated to the processes from the process set P. Now, here it is also to be understood that resources that are there in the system may be of different types in context to the number of instances it has. A resource may be a single instance resource, or a resource may be multi-instance resource. For an example, in a given architecture, processor is a resource. So in some of the architectures you'll find multiple processors, whereas in some of the architecture you'll find a single processor. So in situation where there are multiple processors in a given architecture, then we can say that there are multiple instances of the resource processor. Whereas in case of an architecture where there is a single instance of a processor, so we can say that there is a single instance of the resource processor in a given architecture. So this is what best explains the difference between multi-instance resource and a single instance resource. So it may so happen that in a given architecture there might be resource of different types depending on the number of instances it has. So it may be either single instance resource, or it may be either multi-instance resource. Now, as expected, resource allocation proceeds in the following manner. Any process that is wanting to utilize a resource in order to perform certain purpose-specific tasks has to request for a resource first. So this is the first operation that a process is expected to perform whenever it wants to utilize a resource in order to perform operation. So it has to request for a resource. Now, when a process requests for a resource, there might be two types of, or two cases possible, or two situations may be possible. In the first case, the requested resource is available. In that context, or in this context, the resource can be allocated to the process so that the process performs operation and eventually releases it. In situation when the resource is not free and is held by some other process in the system, then the process that is requesting for the resource has to wait for certain definite period of time. Now, the time for which a process waits for resource to be assigned to it or allocated to it is called as the waiting time. And the time during which the process waits, the process stays in suspension mode. So a process is considered to be suspended until the resource is available. Now, this is the first activity that is performed by a process wanting to utilize a resource in order to perform operation. So one has to request for a resource. So based on the availability of the resource, whether it is free or whether it's not, suitable decisions are made whether to keep a process pending or to let the process perform its desired behavior. Now, once a resource is allocated to a process, then the resource is utilized by the process in order to perform action. So this is the second activity that the process performs. It utilizes the resource in order to perform operation. Then eventually, once the operation concludes, the resource is to be released by the process so that the resource can be utilized by some other process that is there in the system. So the third activity that the process performs is called as release. So you have request, use and release chain that is followed by all the process wanting to use reuse a resource in order to perform a desired operation. Now let us try and understand some of the fundamental assumptions related to allocation of resources. The first assumption is that a process must request for a resource before using it. A process must request a resource before using it. Once the requested resource is assigned to the process should use the same in order to perform the desired behavior. Once it concludes the use of the resource, then it must release the resource in order to enable other processes to use it. So a process must request a resource before using it. It should use the same once assigned, then it must release the resource after using it. So this is the first fundamental assumption of resource allocation. The second assumption says that a process cannot request a number more than the total number of resources available in the system. Now this is to be understood in two different contexts. One is from the number of resources that the system has. Say for an example, a system has in it 10 different types of resources. So a process cannot ask for resources that is more than 10 or types of resources that is numerically more than 10. So a process cannot ask for number of resources that is more than 10 in situation if a system has only 10 different types of resources. That is the first context. The second context is in the number of instances, in regards to the number of instances. So for an example, if a resource R1 has 3 instances of it in the system, so a process cannot ask for more than 3 instances of resource R1. So that is what this particular point or this assumption implies. So a process cannot request a number more than the total number of resources that are available in the system. So this is in context to number of resources and the number of instances of resources. So these are the two fundamental assumptions that are taken into consideration whenever resources are assigned to processes. Now, taking into view all of this, whatever we have discussed, let us draw a definition of deadlock. In a multi-programming system, processes request for allocation of resources. If the resource requested are being held by other processes, then the process enters into waiting state. So this is what we have learned. So whenever a process requests for a resource, and if the resource is being held by some other process in the system, then the process enters into waiting state. However, if the process holding the resource are also in a waiting state, then this leads to a situation called as deadlock. So this is what is deadlock. So if the processes holding the resource are also waiting for some other process to release the resource, then this situation is called as deadlock. So in a multi-programming system, processes request for allocation of resources. If the resources requested are being held by other processes then the process enters into a waiting state. However, if the processes holding the resource are also in waiting state, then it leads to a situation called as deadlock. Now let us formally define deadlock. A set of processes in a deadlock state is in a deadlock state if every process in the set is waiting for an event, that is release of the resource, that can only be caused by some other process in the same set. So if a process is waiting for resource that is being held by some other process, and the process that are holding the resource are also waiting for some other process to release the resource, then this situation is referred to as deadlock. So this is the way how we need to define deadlock. Now let us try and understand the 4 important conditions taking into account which deadlock occurs, right? So a deadlock occurs if and only if the following 4 conditions hold true in a system simultaneously. So all of these 4 conditions have to be simultaneously true, or it has to be true at the same time for a system to enter into state of deadlock. Now the first condition is called as mutual exclusion. Mutual exclusion states that at least one of the resource in the system being utilized by the processes is non-shareable. This implies there has to be at least one resource in the system that the processes that are there in the system utilizes in a non-sharing mode. That means whenever one process is utilizing the resource, the other process should not utilize the resource. So this is the primary condition for deadlock to happen. So at least one of the resource that is there in the system being utilized by the processes should be non-shareable. So if one process is utilizing the resource, no other process should utilize that particular resource. So it's specified here also. That is, only one process can utilize it or use it at a time. And if it's requested by a process while it's being used by another one, the requesting process has to wait until the resource is released. So this is the primary condition for deadlock to happen. The second condition is hold and wait. There must be at least one process that is holding at least one resource and waiting for other resources that are being held by other processes. So there must be at least one process that is holding at least one resource and waiting for other resources that are being held by other processes. So this is called as hold and wait, wherein a process holds a resource and waits for another resource that is being held by some other process. Third one is called as non-preemption. So no resources or no resource can be preempted before the holding process completes its task with the resource. So this is very much, so no preemption basically means no resource can be preempted before the holding process completes its task with the resource, and they are considered irreversible. That is, unable to reset the state where the resource was not held. So once a resource is allocated to a process, then the process utilizes the resource in order to perform operation. In due course of time, no other process can preempt that particular resource in order to make use of it. So here the process that is requesting for the resource can make use of the resource only when the resource becomes free from the process that is holding that particular resource. So a resource can be released voluntarily by the process. So this depends on the need of the holding process. But no resource can be preempted. That implies whenever a resource is allocated to a process, until unless it's not released, it is held by the process that is allotted the resource, and it releases it only on the completion of the desired task. So that is called as non-preemption. The fourth one is called as circular wait. Now there exists a set of processes A to Z, that is of waiting processes, where A waits for resource that is being held by B waits for resource that is being held by C, and eventually Z waits for resource that is being held by A. So this is called as circular wait. Now this is a very, very simple condition where the processes wait for each other to release the resource. Now these are the four conditions that should simultaneously happen in a system for a deadlock to happen. So there has to be mutual exclusion, there has to be hold and wait, there has to be no preemption, and there has to be circular wait. So these are the four basic necessary conditions for deadlock to happen in a system. So in today's class, what we have learned about is what are the fundamentals associated with deadlock. We have learned about what is the expected sequence of action to be performed whenever a resource is to be utilized by a process. Then we've learned about some of the important assumptions that are taken into consideration whenever resource allocation is done to the processes. Then we defined deadlock, take into consideration certain instance, and then we formally defined deadlock. Then we learned about the four important necessary conditions when encountered deadlock. The system will enter into a state of deadlock. But the condition is that all of these four conditions should hold in a system simultaneously. So these are mutual exclusion, hold and wait, no preemption, and circular wait. So these are the four conditions when happens simultaneously makes the system enter into a state of deadlock. So in the next class we'll start with resource allocation graph. Thank you very much. Till then, have a good day.